Hello and welcome. I welcome you all to this session on Introduction to SPSS. My name is Khwaja Fawad Latif, and I'm currently working as Assistant Professor in Department of Management Sciences at Comsats University, Pakistan. Um Before we start, I guess we shall wait so that more and more participants can start join in, and then obviously we'll get going. And I'll introduce myself a little more in a short while.
I think before joining, let me introduce to our host, our guest speaker.
Please, thank you.
Sorry for late because I was trying to reach this meeting. I couldn't get it. Good morning and good afternoon to people who joined from Pakistan and China, I think different time zones. Thank you all for joining this webinar on SPSS. And I hope some people might join us in a while, I guess. Let me give you a short introduction to our guest speaker and my mentor as well, really, because Dr. Fawad Latif helped me out throughout my PhD and throughout my career, who gave me his precious time to conduct this webinar with you guys. Dr. Khwaja Fawad Latif is currently an assistant professor at Comsat University, Islamabad, and holds a PhD degree in human resource management. He published over 20 refereed papers in international journals in areas of knowledge management, corporate social responsibility, project success, knowledge-oriented leadership or leadership, internal marketing, and service quality. His expertise include scale development, symmetric and asymmetric analysis, and multi-level modeling. He authored several peer-reviewed articles and attended international conferences. Thank you, sir, for joining. It's our pleasure indeed. Sir, the ball is in your court, so I think if you want to start, so you can start, or if you want to wait, so you can wait.
Okay, thank you, Umar. Let's start. Thank you for the nice introduction. I welcome you all in these times where we are stuck in home. I hope every one of us and every one of you and your family and your loved ones are safe. Please stay home and stay safe. Umar had this idea to make this time more productive and to utilize this time in a more proper manner so that we can improve our learning. So we decided that, okay, we'll obviously do a number of different sessions on different areas that people would like to improve on. So we are starting with very basic concept or very basic training. In this session or in a series of sessions today, because the timing is limited with Zoom. So I will be focusing on the basics of SPSS. Let me also guide you as to what we plan to do in future. We plan to obviously take this as a breeding ground for our interaction, and we'll be focusing much more on different detailed research areas that would include both writing and analytics as well. So we are planning a number of workshops that would include how to write your paper, how to publish your paper, and in writing, we'll be focusing on all the sections of a good paper. So we'll be focusing on those things as well. With pertinent to analytics, we'll be focusing on Smart PLS, SPSS, which we are going to do now. And then we'll be focusing on AMOS as well. As far as other softwares are concerned, we'll be focusing on Atlas.ti, that is actually used for qualitative analysis. So let's start. If you've got any question, I would request that you keep a note of your questions, and I'll take your questions right at the end. Kindly keep your mic mute because then there'll be noise and I might not be able to communicate with you effectively. Okay, let's start. Now, what you see on your screen is the software, SPSS software. So it looks similar to an Excel sheet. Now, in the past 3, 4, or maybe 7, 8 years, things have changed. SPSS was normally used to a great deal, and but now things have changed, and now people have focused on using modern softwares, SEM softwares like Smart PLS, AMOS, M+, and other softwares. But still, the advantage or the usage of SPSS hasn't gone dead. So we still use it more or less for descriptive analysis, descriptive statistics, data entry, and sometimes for comparative analysis. Although for causal analysis, for basic correlational model, we go for Smart PLS or AMOS. So let's start. So what you see in front of you is a screen, and you see these little boxes. It looks like an Excel sheet. So at the top of the screen, you see these columns are variables, and these are rows where you enter your data. Now, each row attribute, in case you are doing your primary research, would attribute to a response from a single respondent. So your respondent number 1 would be here, respondent number 2 would be here, respondent number 3 would be here, respondent number 4 here, so on and so forth. Now, before you start entering your data into the data view, which is right at the bottom here, you need to define your variables. Now, the first thing that everyone should do is they should define your variable. Now, how do you define your variables? So in order to define your variable, you click on the variable view, and here what you see is, you see this column with title, name, type, width, decimals, label, values, missing, columns, alignment, measurement, and role. Now, each variable should have a name. So for instance, you've got a questionnaire in front of you. Let me share one questionnaire so you can see how a questionnaire might look. So this is how a questionnaire might look to you. So there are 47 items in this questionnaire. And at the top of the questionnaire, there are these demographic data that is required by the user to input. Now we have to define each and every single variable in our data set. Now this is, let's discuss this in a little detail. Now this is one variable, task conflict. This is defined by or measured by 4 items. So this variable task conflict is further divided into 4 different variables that actually define or actually explain the concept of task conflict in our research. So we've got 4 variables here. Task conflict divided into 4 variables. Similarly, relationship conflict divided into another 4 variables. Process conflict divided into 5 variables. So these 5 variables are actually indicators of that particular variable. Now, how do you enter this data into SPSS? Now, in order to enter this data into SPSS, what you do is let's say our first variable is gender. Now, here is the important part. Since we are using SPSS, which is Statistical Package for Social Sciences, since it's a statistical package, so every data that we enter is based on numbers, or shall be based on number. That will make your life much easier. So even if you are using a purely qualitative variable like gender, maybe color, or maybe any other variable. So you obviously you try to categorize the responses into different categories and give each category a number. So in this case, gender can be either male, female, or maybe transgender. So what we should do is we should number these responses. We'll come back to that later. Now, the type is numeric. Width refers to number of digits a variable can hold. And if it's a string variable, it will be number of characters. So there are a number of different variables. It could be numeric, comma, dot, scientific notation, date, dollar, another custom currency, a string, a restricted numbers, integers with leading zeros or anything. But in most cases, we use numeric, or in some cases we go for string. And if you're doing in finance, you might go for custom currency or dollar. In this case, we'll keep it simple and let's focus on numeric. So gender, it doesn't require any decimal points. So what we'll do is we'll put a 0. Now what's label? Now by the name of it, the variable name gender, it's clear what this variable will hold. This variable will hold male, female, or transgender. So we do not actually need a label to it to define that particular variable. We'll come back to this once we define other variables. Now values, we can have predefined values that may fall into a particular variable or what we may store in a variable. So in this case, let's say if we type 1, this would mean male. If we type 2, this would mean female. And then what we do is we press OK. So now if you see, you've defined the variable gender and it can have only 2 values, male and female. But this does not mean that SPSS won't allow you to add any other variable or any other values into this variable. This is because there's no restriction to add data to a particular variable. So you have to be very cautious while you are entering your data. Missing, if there is a missing data, if somebody hasn't mentioned the gender, you can represent the missing values through different discrete, any other values, or any discrete value, or any range. What you can do is you can have no missing values, leave it empty. Now what is column? Column is the width of the column. If you look at this column here, gender, which we defined in the variable view, look at the width of the column. Now I want to increase this width, for instance. So what I'll do is, let's say if I type 18, and if I go back, see the column, the width of the column has increased. Now, what is alignment? It has to do purely with the readability of the data. You can align your data left, right, or center, whatever you want. Now, let's focus on the next thing, which is measure. This is very important. You need to understand what is the measure of your variable. Now, there are different scales of measurement in research. There's nominal scale, there is ordinal scale, there is interval scale, and then there is ratio scale. Now, if you see, I've mentioned 4, but here you can only see 3 scales. There is nominal, there is ordinal, there is interval, and then there is ratio. But in this case, the interval and ratio is clubbed into scale. Now, what are these scales? For detail, obviously, you should refer to the book by Uma Sakran, The Skill Building Approach, or the Research Method for Business Students, a Skill Building Approach. But here, we'll discuss it in a very brief manner. A nominal scale variable is one where the variables do not have any inherent order. The variable has categories and the respondent may fall into one of those categories. For example, if you have asked a respondent about their gender, they may be male, they may be female. So these are heterogeneous groups in which people may fall. For example, if you have asked the people about their grade, so they might say that, okay, they are 17 or 18 grade, but in here there is an inherent order. Grade 18 is obviously higher than grade 17. So when you are putting a variable in ordinal scale, the variable will have categories in which the people will fall. Along with that, there will be an inherent order in those categories, just like a job rank may be junior, middle, senior, just like position may be first, second, third. Then there is interval and ratio scale. Now, in interval and ratio scale, the data points in your variable, once you have the values in your data, the data points will have equal interval in ratio in interval scale. For instance, let's say I ask you a question. I ask you, okay, what is your age? So you say, okay, my age is 26. So I may ask another person, what is your age? And that other person may be Umar, and Umar says, my age is 31. And so on, and I keep asking people about their age. So once I have all these ages, I can obviously create classes in these ages from, say, let's say 21 to 25, 25 to 30, 26 to 30, 31 to 35, 36 to 40, 36 to 40, and 41 to 50, and so on and so forth. Now, in each of these classes, the interval between these categories is the same. The distance between the age 21 to 25 is the same as the distance between 26 to 30. That is 5 years. So the interval remains the same. And in ratio scale, what happens is that you can have a true zero in a particular variable. A variable can have zero, can take the value of a zero. And in that particular case, the zero actually means zero, and it does not have any effect. For instance, what if I ask someone, or maybe what if I ask a person working in my university as an assistant? What if I ask him, how many publications do you have in maybe say 4-star journal? He would say, well, 0. What if somebody asks me, how many publications do you have in 4-star journal? I would say 0. So here 0 means 0. This is true 0. But there is another 0, which is arbitrary 0. Let's say, if I say the temperature is 0 degrees centigrade, here the temperature has a significant effect. You will be shivering in a temperature with 0 degrees centigrade. The effect of temperature is not null in this case. It's not true 0. There is an effect of temperature. So in ratio scale, you have a true 0. So why is interval and ratio scale clubbed together? And why not nominal and ordinal clubbed together? The reason is the measure of central tendency used for the variables that fall into these scales. Now, if a variable is in nominal scale, the measure of central tendency is mode. And by mode, we mean the occurrence of a particular value in a particular data set for a particular variable. So if you've got 10 people and 6 of them are male and 4 of them are female, your mode would be obviously male. And in ordinal scale, the measure of central tendency is median, the middle value. But first we have to arrange the values from lower to higher or higher to lower. But in scale, the measure of central tendency is mean, average that we take. You would not have seen any research paper where they have reported the mean of the gender. Why? Because the measure of central tendency for gender is mode, not mean, not median. So this is a brief discussion on the scaling of the variables. So in order to further study this, I would strongly recommend that you use Umar Sakran book on research methods for business students. Now the role is input. We're not going to discuss the other roles for now. So there can be split, or you can split your data. You can have partition of your data. And in this case, we'll leave it as input because we are entering the data. Now let's define another variable. Let's define age. Age is a numeric variable, and obviously it cannot have 8 digits. Maximum age that we will get is maybe 3 digits. That's it. And it depends on respondent. Let's keep it 8. We don't mind. The decimal, if you want to keep it, you can keep it. Otherwise, you can leave it or make it a 0. Now, I'm not obviously what I'm not doing. I'm not obviously classifying the age into categories. But what if I want to? What if I do? Obviously, I can add, for instance, say if 1 means the age ranges from 21 to 25. and so on and so forth. You can do it like this. But what you can do is you can keep age as open-ended and categorize it later. I'll do it for you in a short while. Okay, let's. This is a scale variable. As I discussed, this falls in interval scale because age cannot be 0. That's why it is not a ratio scale variable. Now, as I showed you the questionnaire, let's say we have got a variable called process conflict or task conflict, or maybe a relationship conflict, or maybe servant leadership. And it has got 7 indicators, 8 indicators, 4 indicators. Now, how do you define these variables in SPSS? In order to do this, what you do is, the best approach is, since it's, let's say it's task conflicts, so I use the initials, task conflict, TC1. Now, how would I know what is TC1? Here you can write the full question, the full description of the question. Let's say the first question is, the label is this. So what I've done is I've written the full question. What does TC1 means? TC1 means that there are rarely explicit conflicting opinions during management team discussions. Let's say, what is TC2? Maybe TC2 is this. So, and similarly, you can define all your variables in here. So, but there are predefined values that these variables can take. Let's define them. So 1 means strongly disagree, and then you press the add button. 2 means disagree. 3 means neutral. 4 would mean agree. 5 would refer to strongly agree. So you have defined your Likert scale in the values from strongly disagree to strongly agree. There are obviously 2 ways to do it. Sometimes people keep strongly agree as 1 and then strongly disagree as 5. What I have seen with my experience is that people tend to have this notion whereby the agreement scale is always, or they tend to associate with a higher number. So obviously you can have your own opinion, or your supervisors can have their own opinion, but I prefer this scale, and this is what my experience has guided me to do. Now, once you have done for a particular variable, you can just copy it, press Ctrl+C, and you can just paste it here. So it's pasted. You do not have to write it over and over again. Let's say we have got another variable TC3, and then we've got TC4, and you want to copy it again. So just press Ctrl+C and then paste it. Now, there might be a question in your mind. Okay, what scale does it fall in? It falls in interval scale. Now, why do I put it in interval scale? I'm just going to give you the reference. Nunnally, a famous statistician, and he said that the psychological distance of choice between strongly disagree, and the distance of choice between the 2 data points in a Likert scale is the same. So since we are not dealing with pure statistics, we are only using statistics for our own, to have a more conclusive opinion about our research. So we take Nunnally's opinion, and this is widespread and everybody uses it the same way. So let's say we've entered the data about these 4, or we want to enter the data about these variables now. So what we do is we go to the data view, and here we can see all these variables: gender, age, team conflict 1, team conflict 2, team conflict 3, team conflict 4. So let's say we've got 200, 300, 4 questions right in front of us. 300, 400 questionnaires in front of us. The best practice to enter data is that you number your questionnaires, the papers that you have in front of you, and even so if you number them, and if you encounter an error later on, you can obviously go back to your paper questionnaires and identify what was the right value. So in order to do this, what you should do rather is, let's say I've got the first questionnaire. So what I do is on the bottom left, on the top left, on the top right, or bottom right, whatever, you can mention one. So let's say the first respondent was male. The age was 26. And for team conflict, for the first statement, he said agree. For the second statement, he said strongly agree. With the third statement, he said agree. With the fourth statement, he said strongly agree. Now, the first questionnaire is done. Let's go with the second one. The second was female. Age was 23. Let's say 2, disagree, strongly disagree, disagree, strongly disagree. And this way you keep on entering your data till you reach the end of your data set. Let's say, let me enter some data here. Let's enter some dummy data. So let's say I've entered another variable. So you just click it, press delete, and it will be deleted. Okay, let's create this data, and then okay, now let's say we have got this data, and let's say this is our data. This is what we have entered. Now I want to find out how many males and how many female respondents I have. So in order to do this, this is not that difficult. So let's say these are our respondents. Now I want to find out how many male respondents were there and how many female respondents were there. Now, in order to do this, what you should do is, or what you can do is, you can go to Analyze, and this is the main menu where we work. This is got more or less it's got everything in there. So what you can do is you can go to Analyze, Descriptive Statistics, and Frequencies, and then you see Descriptives, you see Explore, then you see Cross Steps. Now, when do you use Descriptives and when do you use Frequencies? Now, if your data is categorical and it has got classes, so you more or less you go for frequencies. But if your data is in interval or ratio scale and you want to find out about certain inclination of your respondents, so you go for descriptives. We'll be doing this in detail. Let's first answer this basic question. I want to find out how many male or female respondents I have. So what you do is you press this frequencies, and I'm interested in finding out about gender. So I'll do it again. Just select the variable you are interested in, press the arrow button, and then it is displayed in the variables list box. So since it says variable, you can add more in here. Let's see what statistics we can use. So we can go to statistics. And I'm interested in finding out the minimum value and the maximum value, just in case, so I know that I've entered the data correctly. Because I gave the data a range 1 and 2. So, and I'm not interested in mean, obviously, because gender does not have a mean. I'm interested in mode because gender is a nominal scale variable. And then we press continue and we press, okay, we can have charts as well. You can have bar charts, you can have pie charts. In this case, it is more suited that we have pie charts. We press continue and we press OK. So this is the output window where the results are displayed. It may take some time based on the data you have. Okay, here are the results. So if I see this table, this statistics table, and the sample size, we have got 30 valid responses. There is no missing data. The mode is 1. What does this mean? This means that the higher number of respondents are male. The minimum value is 1, the maximum value is 2. This means that you haven't entered any incorrect data. Now, if you go to this gender table, you've got male respondents, then you've got female respondents. You've got 18 male respondents, and then you've got 12 female respondents. The percentage is 18 makes up 60% of the respondents, and female make 40% of the respondents. The valid percentage and cumulative percentage. Now, what does this valid percentage mean? I'll get back to it in a minute. And this is your graph. So what you can do is you can easily just copy these graphs and put it into your Word document. Or if you want to edit the graph, what you can do is you can double click on the graph and you will be you will see the chart editor. And then you just single click on this and then another single click, and this will give you a chance to edit gender distribution of the respondents. So here I have edited it. And then what you do is you just press close it and see you have changed the caption of the graph. Now, okay, what does this valid respondent mean or valid percentage mean? This means that the percentage without any missing values. So the valid percentage will count the frequency and take its percentage when there is no missing data. So let me give you an example how you do it. Let's see. So let's say if you've got missing data, let's say the first respondent did not enter the gender. So if we go to analyze descriptive frequencies and then we press OK. So if you have a look at this output now, I hope you can see the charts clearly. So if you see the output now, previously for male, it was 18 respondents and the percentage was 60. And the valid percentage was the same because there was no missing data. But in this case,
excuse me, sir. Sir, you need to share the other version, like the tables. We can't see that tables.
Okay. Sorry. Let me do it. Can you see the screen now?
Yes.
Okay.
Yes.
Okay, I'll get back to it now. I'll do it again. Okay. So once you press that frequencies button for gender, what you see is this output window. So once you see this output window, you see these statistics, you see the gender table, and you see the graph. Now, if you look at the statistics, this shows that the valid number of respondents is 30. There is no missing value, 0. The mode is 1. This means that majority of the respondents are male. The minimum value is 1 and the maximum value is 2. This shows that you haven't entered any data incorrectly because the gender was to be 1 or 2. Now this is the descriptives table. Gender, male, you've got 18 male respondents, you've got 12 female respondents. These 18 make up 60% of your respondents, and female make up 40% of your respondents. The valid percentage is the same as percentage. The valid percentage actually means that what's the valid data or the percentage of valid data. So I'll be coming back to this in a minute. Cumulative percentage, obviously the preceding percentages are added and the end percentage is always 100. Now if you look at this graph, this shows that, okay, the green female respondents and the blue refers to the male respondents. You can edit the graph easily by just double clicking on the graph. And what you do is you just double click on this and then you can say gender distribution of respondents for the data, let's say. And then you just close it and it's there, the addition is, or whatever editing you've done with the graph is there. Now coming back to the valid percentage, here you see it's 60 and the female is 40% because there is no missing data. Now if we have a missing data, let's assume that one of the respondent did not mention their gender. And then if you take frequencies, what you will get is you will get this. In this case, if you see that there are 29 valid responses for gender, and there is one missing values. This is what I was referring to. One of the respondent did not enter or did not provide their agenda. The mode, the minimum, maximum, all are fine. If we look at this now, male respondents are 17. Their percentage is 56.7. This is calculated by 17 divided by 30 multiplied by 100. So we will get is 56.7. Okay, now valid percentage. What is valid percentage? Valid percentage will only calculate, will only attribute, will only use, 17 divided by 29. Let me do it. Okay, wait. Okay, so valid percentage is that it will not attribute, it will not include the missing data. But percentage will include the missing data. So 17 divided by 30 multiplied by 100 is 56.7. But 58.6 is 17 divided by 29 multiplied by 100. So valid percentage will not include the missing data, but percentage will include the missing data. So this is what the difference is between the percentage and the valid percentage. I hope I've made myself clear. Now, going back to our data set. Now, as I mentioned earlier, that, okay, I've asked the respondents about their age, and they have entered their age in numbers. Now, let's say the journal in which I'm submitting my paper or my supervisor has asked me to categorize this age. Like he wants to have classes. Okay, how many of them were from 21 to 25? How many of them were from 26 to 30? How many of them were from maybe 31 to 40, or whatever the range is, whatever the classes are. So once you have entered the data into SPSS, you can easily classify your data. Now, in order to do this, what you do is you go to transform, and there are two options: recode into same variable and recode into different variable. Now, to do this, what you can do is, I would recommend the good tip, the best practice is you keep your original variable intact and recode into a different variable. So you create a new variable based on this variable. So recode into different variable. What variable you want to code? I want to code age. So I select age. Now, since you are creating a new variable, you have to give it a name. So let's say I give name age underscore gr. So I'm grouping the age. So let's name it age underscore gr, and then I press change. So you have to press change, and then what you do is you click old and new values. But before doing this, you need to do one more thing, and that is you go to analyze descriptives. I mean, before you create classes, before you create any grouping, you should know what was the minimum value and what was the maximum value. Failing to do so, you cannot create classes. This is basic statistical principle. When you do classes and when you create classes, you should know the lower value and the higher value. Now, how do you know the lower and higher value in SPSS? Same, you go for frequencies. So what I'll do is, let me add age to the variable list. I'm interested in identifying the minimum and maximum value. In this case, I'm not interested in the central tendency, and I press OK. Now, the minimum value is 23, the maximum value is 43. So you can create classes in any way possible that you want. For example, in this case, I would create classes 21 to 30, 31 to 40, 41 to 50. So I'll be having 3 classes. You can have maybe say 6 classes: 21 to 25, 26 to 30, 31 to 35, 36 to 40, and so on and so forth. Sorry, again, my screen, just let me do it. Okay. Okay, see this screen. The minimum value is 23, the maximum value is 43. The age, obviously this table is showing you that, okay, you had 4 respondents who had age 23. You had 8 respondents who had 26. You had 1 respondent who had 31. You had 1 respondent who had 32. This table, as is shown here, does not make much sense. It would be better if we can classify the age into groups. Now, in order to classify, you have to have the minimum and maximum value. In this case, the minimum age is 23 and the maximum age is 43. Now, in order to create this group or these classes, you can easily do it in SPSS. So in order to do this, what we do is we go to transform. And as I mentioned before, you have to make sure that you have the original data intact. You might need it in future. So let's keep the original data intact and we do recode into different variables. Now, which variable we want to code? We want to code age. We select age. And what we do is we give it a new name, age underscore gr. Change. You have to press change so that the name is loaded onto this list box. The next step is you click old and new variables. And then what we have done is, or what we have decided to do is that if the data is in a certain range, it would attribute to a certain value. So what I've decided, or what I decided is that, okay, if it's in the range of 21 to 30, I would say it's 1. So I would refer to that particular class as 1. So if the data is from 31 to 40, I would refer to that class as 2. So I enter 2 in the new value and press add. If the data is in the range, or if the age is in the range of 41 to 50, I would refer to that particular value as 3 and I would press add. Then I press continue and then I press OK. So if you look at your data set, here is a new variable and it only shows the number 1, 2, and 3. So now you have created classes and you have referred to them as 1, 2, and 3. Now, it's better you define these classes in your variable view. Why? Why do you need to define your these classes as to what is meant by 1? Because nobody would know what is 1, what is 2, what is 3. So it's better that you define these. So how do you define this? You go to variable view and you click this values button here, and then you enter 1. 1 means 21 to 30. 2 would mean 31 to 40. And 3 would mean 41 to 50. You add it, you press OK. Now you have defined what 1, 2, and 3 refers to and what is meant by 1, 2, and 3. Now let's take this frequency of this particular variable. Frequencies, age underscore gr. We already have the frequencies there, and then we press OK. Now if we look at the output now, this is the output after we have categorized the variable age. Now this makes much more sense than this. In this case, we had just had a sample data for maybe say 30 people. What if you've got data for maybe 300 people, 400 people, and then in that particular case you would have had maybe say 60 ages? This will be a very big table then, and this won't make much sense. So it's always a good idea to categorize your age afterwards, so to give a more clear picture as to how you actually or how the age distribution is in your data set. So I hope everything is clear up till now. So let's go back to our data set. Okay. Now there is another question, and this question actually troubled me when I was learning these things. Now I'm interested in task conflict. I'm interested in task conflict, but the problem is the task conflict in this case is measured using 4 different items. It is TC1, TC2, TC3, TC4. Same goes for other variables in my study. Same goes for other variables in my study. So maybe process conflict has got 4 items as well. Maybe any other variable has got 4 items, 5 items, 6 items. The servant leadership scale has got 7 items. But I'm not interested in those 7 items. What I'm interested in is I am interested in task conflict as a whole. So what I need to do is some way I need to group these 4 variables, 4 indicators to represent task conflict. So how you do it? You do it in SPSS by taking mean of these 4 indicators. And same goes for any other variable that you have in your study. Maybe servant leadership, it has got 7 indicators in my study. So what I do is, I'm coming, just hold on. Okay. Okay, now how do you transform? Okay, this is one of the disadvantages of working from home. You have to deal with the kids as well. I'm coming. Let's go. Okay, Umar, can you take over for a minute and I'll be back?
Okay, sir. Okay, sir.
Yeah, just
sure.
you can ask if somebody has got any questions, you can obviously take note and I'll be back in just 2 minutes. Yep.
Okay, sir.
Okay,
Sure.
thank you, Umar.
Guys, if the call has been disconnected, so I will share another ID on a portal so you guys can join that as well. Because Zoom won't allow like more than 40 minutes. And if someone have any pro ID, so he or she can share, so we'll join that group as well.
Okay, sorry for the inconvenience. You might have seen that BBC video as well, where they highlighted the disadvantages of working from home. I've got a small kid, so obviously there was some. Okay, really sorry for the inconvenience. Okay, Umar, what do you want to shall we take some questions? Okay, let me do this one and then we'll take questions. Okay.
Okay, sir.
Yep. Okay. Now, so I'm interested in task conflict as a whole. I'm not interested in what TC1 refers to, what TC2 does, what TC3 or task conflict 4 does. I'm interested in the impact or assessment of task conflict as a whole. So what you do is you go to transform in order to create a single variable out of these indicators. So what you do is you go to transform and then you click compute variable. So once you do this, you are presented with a dialog box. So first you have to, now since you are creating a new variable out of these indicators, so you have to first name your target variable. In this case, I'm referring it, or I'm going to name it TC. And in the numeric expression, what you do is you can write, what you do is you write mean, MEAN. And then parenthetical bracket. And then you add these 4 variables that you want to combine. So in this case, it's TC1 separated by a comma, TC2, comma, TC3, comma, TC4. And then the parenthetical bracket ends. And what you do is you press OK. And if you look at your data set, a new variable is now created. And this 4.50 is the average of these 4 questions. This 1.50 is the average of these 4 questions, so on and so forth. So now, what if, because normally the supervisor are supervisors, the editors, the reviewers are interested in these things, and you would have seen this as well. What if you are interested, or your supervisor asks you to provide a descriptive statistics for a particular variable? Maybe say it's team conflict, maybe it's process conflict, maybe it's relationship conflict, maybe it's internal marketing, maybe it's servant leadership, maybe it's entrepreneurial leadership, any variable. So how do you average, how do you identify, or how do you take out, how do you assess, how do you establish the average of a particular variable? Now, in order to do this, plain and simple, you go to analyze, you go to descriptive statistics, and then you go to descriptives. And then I'm interested in the average of task conflict. So I select task conflict, and then I press the arrow button and just press OK. So it is giving us this table. Let me share that as well. So this table here. So we've got 30 respondents. The minimum is 1.50. The maximum is 4.50. The mean is 3.10. Now, how do you interpret this mean? Now, if you remember, the scale was from strongly disagree to strongly agree. So there is a certain inclination towards the higher score. So this means that there is a certain amount of task conflict prevalent in the respondents. The standard deviation is 0.98. It should be lower than half of the mean. And in this case, there is not much deviation from the standard. So it's normal and it's fine. So the mean is 3.10. This shows that there is a certain amount of, because it is above the neutral value. So this means that there is a certain amount of task conflict prevalent in the organization. Similarly, you can take average for any other data. Now, okay, before I move on into how do you, or when or where you interpret these things in a research paper or in a research thesis, I think I'll open the floor for a few questions if there are any. Umar, if there are any questions, let's take some questions.
Guys, please ask questions if you have any.
Sir, I have a question.
Yes, please.
Can you guide us how we will save this data when we enter this all?
Sure. Sorry, I didn't mention it earlier. There is this disk button. You can just press this. Let me share the screen again. Just hold on. Okay. If you see the screen, there is this disk button. If you press this button, you can save it wherever you want. Again, it's strongly recommended because people do not take care of these things. They save their data anywhere they want. Save it in the same folder where you've got your research or the material for your research. Create a separate folder. This thing might seem very trivial or very least important to you for now, but with my 10 years experience with data, this becomes severely big when you've got multiple data sets going for a similar research or same research. So you get into a lot of trouble finding the right data set. So always make sure that you give it a meaningful name. For example, let's say this is my task conflict. This is my research on servant leadership, task conflict, and team performance. And I saved this data on 13th April 2020. The extension is SAV, and you can obviously save it into a comma delimited file, tab delimited file, but in this case, it's the extension is SAV. We'll use this, and then you press the save button, and it's obviously saved onto the desktop. Let me share. Okay. So it's here. So you just double click it, and then obviously it's already open. So it's asking you that you want to open it another file. So this is how you obviously share the or save the data. You can save it into different formats. When we will be obviously discussing about Smart PLS, we'll see how to save it in CSV format. If the time allows, and if you do any other kind of software, maybe Amos, so we'll see how you can use it in Amos and other softwares as well. I hope this answers your question.
Yes, thank you so much, sir.
Thank you.
You're welcome.
Okay, any other question?
So another question struck my mind.
Yep.
So in case that we are like you did the analysis for gender and age and TC. In case I did it for gender one day or one time, and in second time I did it for age and then so on. So I should save in the same file or should create different separate files?
Okay. Now, the best practice is, let's say I've got. You can obviously it depends on you how you find it easier. The best practice would always be do not save the output files, but what you do is you save your data from those output files. I hope you can see my screen, right?
Yes.
Okay. The best practice is you can save this output, but saving output in a same file, because you will have so much output that later on finding the right output would be difficult for you. So the best thing is you use this data when you've got output, just copy your results. Let's say I want this table to be copied. So what you do is you just select this data, either you right click on it and press copy, or you press Control C and you put it right into the Word document where you want it to be. Otherwise, it's up to you. You can have separate output files for each analysis, or you can have the same output file. But whenever you rerun an analysis with the output file closed earlier, it will generate a new output file. The best thing in order to avoid any confusion is that you copy your data right away, the output right away. And how do you do it? You just let's see this. Let's say this is the Word document we have, and I've got this table. I've selected it and I've pressed Control C. In order to save this output, you just press this save button, and the output has SPV extension. You save it wherever you want, and you can later open it by double clicking the file. So what I do is I just copy that table and just paste it here. Now, there's one important thing that one should understand. You just don't just copy and paste your data from the tables in SPSS to your Word document. You format your tables into a particular style. If it's a thesis in Pakistan, we more or less prefer APA style. But more or less, even the journals that that me and Umar we submit to, we use APA style. And if they ask us to change the style, like recently we published in ASLIP journal or Leadership and Organization Development journal, they asked us to do a Harvard style formatting, if I'm not wrong, Umar. So we did change the style later. So the thing is, whenever your thesis is being evaluated, let me give some tips as well. Whenever your thesis is being evaluated, when your paper is being evaluated, apart from the content, the most important thing is your structure and your format, because this shows that how professional are you. This shows how serious were you in conducting research. If you just copy and paste your tables, if you just copy and paste your data onto the Word document and do not format it, do not structure it, this shows that you are not serious about research. So what you do is you format your table. Now, how do you do it? It's plain and simple. The first thing you do is, let's have some space above. So you first delete this particular description that SPSS has given by itself. So what you do is you press the shift button, you press the end button, and then you press the backspace button. So the first row is deleted. The second thing you do is you select this table by clicking this indicator, and then you select and then you press all borders. Now all borders are selected. So what you do is you select it again, then you go for it. Select no borders, select bottom border, select top border, and then select the top row and select the bottom border. Apart from leaving the first column, you select all the other columns, and then you press this center alignment. So now your table is in APA style, and this looks much better than the table in SPSS format. So now you give it a caption: table 1, descriptive statistics for the task conflict. Yes, it's not. And what you do is you miss one step and then you put it in italics. Now this looks much better. In order to make it more well formatted, you right click on it, auto fit, and auto fit to window. And the best practice is write the description at the top of the table. For instance, how do you describe the results now? How do you describe this, the mean for task conflict? Mean analysis or task conflict indicate that there is a certain amount of task conflict prevalent in the organization, as the mean is slightly above the neutral value of 3. There can be other means to describe as well. Whatever is suitable for you, whatever you find easy, whatever you find readable, you can do it in any way possible. Okay, I hope this answers the question.
Yes, thank you so much, sir.
Pleasure. Yes, any other question? Any other question or any other particular thing that you want me to discuss further, or shall I continue? Or if you want a 5-minute break, that's also possible. No worries. Umar, can we have a 5-minute break, or shall I continue? What do you suggest?
Sir, it's up to you, I guess.
So if there are no questions, let's keep going.
Okay, sir.
Okay. Now, so now we have done what we have done is we have taken out the means. Now let me search for a particular data set, and then let's run some operations on that particular data set. Or rather, okay, let's say, just give me 1 minute. Let me find out, let me get a data set for you. Okay, what you see is a data set for a study that me and Umar are working on. It's a data set on social responsibility and its impact on loyalty of a customer. It's a study based in 3 different countries. So I'm not going to go into much detail of this study because this study is still in, the paper is in review. So obviously, let's use this data set to run a few operations onto in SPSS. Now, if you see, we've got these variables. If you go to the data view, you'll see that I've got age, I've got gender, then I've got corporate social responsibility and other variables. Let's say Let's first transform it, because obviously I didn't need to transform it because I used SCM. But in this case, for now, we are using SPSS. So how do you transform? Let's first transform a few variables. Let's say we've got CSR, mean. Now the problem is, let's see, it's very monotonous to type each variable's name again and again and again. Is there any easier way to do it? Well, there is one. If you press this button, I'll press it again so you see this button over here. It's variables button. So, and then in the variable view, I select, let's say I select all these variables and I press this paste button. So now I've got all these variables with me. So I do not have to double click or write them on my own. I think you cannot see the screen. So let me see the screen. Okay. Can you see the screen now? Let me do it again. Let me do it again. So I don't want to type the variables when I'm transforming over and over again. So what I do is I just press this variables button. I select all these variables that I'm interested in transforming. I press this paste button and now I've got these variables with me. I just press Control C, copy these variables. You don't need to save it. And let's transform it now. Let's transform, let's compute variable, CSR. And I'm interested in mean for CSR. So I'll just select CSR and I see what's missing is the comma. So I press and separate these variables with comma. And I press OK. And you see this, here it is, the new variable is now created. Similarly, I'll create another variable. Let's say I create loyalty. But I have to give it another name. And then I press OK. And if you look now, there is another variable, loyalty. Okay, let's say we have now created these variables, these two variables. Now, what we did previously was we focused on descriptive statistics, frequencies. But now moving forward, we are now interested in identifying whether or not there exists a relationship between CSR and loyalty. So in order to assess the relationship between variables, we use correlation analysis. There are other things that are available in this section as well, but for now, let's focus on just a few basic things. One more thing. Sometimes as when you are doing your thesis, you are asked to identify whether the data is normally distributed or not. Now, normally, what we do is we use skewness and kurtosis as a mean, as a measure for identifying whether the data is normally distributed or not. Now, to do this, we press descriptives and let's see if my data is normally distributed or not. So what I do is I add these two variables, I go to options, and then there is distribution, skewness and kurtosis, and I press OK and I press OK. So if we see here, the skewness is -0.921 for CSR and the kurtosis is 1.134. It is within the range of ±2. So there is no problem with respect to the skewness and kurtosis, and we can say, well, yes, our data is normally distributed. Well, if we look at the kurtosis value for loyalty, it's slightly over 2. So we can say there is a certain distribution problem. But again, what's the way out? The way out is that according to Naval Bajpai in his book, Research Method, he mentioned that according to central limit theorem, if you've got a data set over 30, you can assume normality. The book is by Naval Bajpai. I'll share it in the text later so that you can refer to it. It's a very good book, a very, very good book. If you can get hold of this book, obviously I'll strongly recommend reading it. So now going back to our data set. So let's assume we have got normality. So what we do is, now I'm interested in finding out whether CSR and customer loyalty, customer loyalty are in fact related with each other, because this is my model. This is what I want to study. Now, in order to do this, what you do is you go to analyze, correlate, bivariate. You go to analyze, correlate, and then bivariate. So once you click it, you are obviously presented with a number of variables on the left-hand side, all the variables in your study. But in this case, I'm interested in just these two variables, CSR and loyalty. So you press this and then leave everything aside. Correlation coefficient, there are 3 different correlation coefficients: Pearson, Kendall-Tau, and Spearman. If you've got your data in ordinal scale, you go for Spearman or Kendall-Tau. If you've got your data in interval scale, as in this case, we go for Pearson. Test of significance, two-tailed or one-tailed. If you know the direction of relationship, if you know that there is a positive or negative relationship in these variables, or this is what you assume that there would be, so you go for one-tailed. But if you're not sure whether there is a positive relationship between these variables or not, let me give you an example. Existing research shows that when there is task conflict in an organization, the performance of the organization, the team performance, could very well increase. But there is other research that has shown that if there is task conflict, this can significantly hamper team performance. So you do not know whether the relationship between these two variables is positive or negative. So you cannot decide whether you should go for one-tailed or not. So you go for two-tailed. In this case, we know that the relationship, or rather, we assume that the relationship is or should be positive. So we can go for one-tailed. Flag significant correlation, that if it's a significant correlation, it gets marked. So what we press is OK, and this is the table we get. Now, let me copy this table onto a Word document so I can easily describe it for you. I hope you can see my screen. I think I've shared it. Yeah, okay. So now if you see this table, there are different statistics in this table. There is Pearson correlation, there is significance, there is N value, then again there is Pearson correlation, significance. Now there are 2 variables that we wanted to find the correlation of. One was CSR, the other was loyalty. Now if you have a look, you see that a few things are repeating. 0.716, 0.000, 0.71, 0.774. Same thing is repeated here, because what you are interested in is the relationship of CSR with loyalty. This is what you are interested in. But the computer doesn't know, the software doesn't know whether you are interested in the relationship of CSR with CL, or you are interested in the relationship of CL with CSR. That's the reason you've got repetition above and below the diagonal, and the diagonal is separated by 1. Now, what is this one? The relationship of CSR with CSR will obviously be absolute. It will always be 1, because let me give you a simple example. If you are standing in front of a mirror, what you see is yourself. So that's the reason the relationship, or the value of the relationship is 1. Now, what is this 1? This is correlation coefficient. The correlation coefficient between CSR and CL is 0.716. Now that we know that the relationship between CSR, and actually we are interested in identifying the relationship of CSR with CL, not CL with CSR, although it's the same thing. Let's remove this bottom to make it more easier to discuss. So I remove this, and then let's do all borders, and then select this, press the shift key, select this bottom column, bottom row, which is further divided into 3 rows, and then you press the backspace button. So it's removed. And I'm left with what I am interested in, CSR with CL. Now, let's discuss it one by one. N here refers to number of respondents, which is 774. It's again repeating, so we can remove it, but let's format the table later. What is this Pearson correlation? This is what we refer to as correlation coefficient. And its value ranges from 0 to 1. This value is from 0 to 1, where 0 is obviously no correlation, and 1 is absolute correlation. So how do you interpret this 0.716? And what does this Pearson correlation tells us? It guides us, it tells us about strength of relationship. So how do you interpret this strength of relationship? And does strength and significance mean the same thing? No, they don't. Strength is different than significance. Something might be significant, but it will not carry the same strength. Let me give you an example, although it might sound harsh, but it's the true fact. We are faced with a pandemic and everybody is staying home. Now, this pandemic started in China. And when it was in China, we could feel that people were suffering, and we could see people were dying. And we felt, okay, this was significant for us. Oh, people dying, and we felt sorry. But still, it wasn't the strength of relationship that, okay, the people are dying. This consciousness was somewhere missing. But then this came to our countries, our neighborhoods. And now we feel associated with this problem. Now the strength of relationship has got strength. It's further strong. And now we are staying home. We are praying that this ends soon. Now we are closely associated with this particular issue, this particular virus, this particular disease, or which actually leads to a very catastrophic outcome. So the strength of relationship has got a certain increase. There is an increase in strength of relationship. So strength of relationship is how change in one variable can change the other variable. Whereas significance refers to, okay, it will change, but how strengthful or how worthy is the change? So let's get back to the topic, and we'll be discussing it further as well. So now, strength of relationship. How do I interpret this strength of relationship? So if the value is less than 0.30, we refer to it as a very weak relationship. If the value is greater than 0.30 but less than 0.50, we refer to it as a weak relationship. If the value is less than 0.70, greater than, we refer to it as a moderate relationship. If the value is greater than 0.70, we refer to it as a strong relationship. Different scholars have given different interpretation, but this is normally used. So obviously, if you come across any other interpretation, like they might have said less than 0.20 is very weak, less than 0.40 is weak, less than 0.60 is moderate, and greater than 0.60 is strong. So obviously you can take it, unless that's not a problem. But what if it's greater than 0.85, or maybe in some cases it's 0.9? What do you mean by 0.9? This means that there is a multicollinearity issue. The two variables more or less are measuring the same thing. But in this case, it's 0.716, which shows that there is a strong relationship between the two variables. Now, what is the significance? Now, why do you need a correlation analysis? Or why do you need a regression analysis? Or maybe why do you need an independent sample t-test or comparison or any other test for that matter? The reason is that you are testing a particular hypothesis in your research. In our case, we proposed a hypothesis that there is a significant relationship of CSR with CL. Now, in order to test this hypothesis, we need to run a test. Now, since we are looking at the relationship of variables, we go for a correlation analysis. Now, once we do a correlation analysis, and since it's a test, and since it's a hypothesis is either accepted or rejected. So we want to be sure whether a hypothesis is accepted or rejected. So we need a particular standard or criteria. Now, in order to test your hypothesis, the criteria in statistical analysis is the significance. So how do you know whether your hypothesis is accepted or rejected? Simple. If your significance value, which is, sorry for my typing mistakes, okay, it's less than 0.05 or equal to even, you would say that my hypothesis, my alternate hypothesis is accepted. If it's greater than 0.05, you would say my hypothesis is rejected. So this is the standard that you use whenever you are running a test to find out whether your hypothesis is supported or rejected or not supported, or your null hypothesis is rejected, or you fail to reject your null hypothesis. Actually, we are never accepting the alternate or rejecting the alternate hypothesis. It's always that you reject your null hypothesis or you fail to reject your null hypothesis. So when you are rejecting your null hypothesis, it means that you are accepting your alternate. When you fail to reject your null hypothesis, it means that you are rejecting your alternate. So now in this case, our hypothesis is accepted because the significance value is less than 0.05. This means that, okay, yeah, it's one-tailed only because I presumed, okay, I'm just looking at the few comments as well. Yes, it's one-tailed because I presume that there is a positive relationship between CSR and loyalty. So once I presume this, I've got it one-tailed. You can have two-tailed it as well if you do not know what that, or you do not know about the direction of relationship. Okay, so I'll be taking questions at the end after this correlation analysis. Okay, let me put it at the bottom. Okay, moving on. So now we know about the significance of relationship. We know about the strength of relationship. Let's say, how do you report it now in your thesis maybe? So whenever you are reporting a test, you first mention your hypothesis. And my hypothesis in this case is there is a significant relationship between CSR and CL. Now this is my hypothesis. This is my hypothesis H1. Now let's see. In order to assess the relationship between CSR and CL, correlation analysis was. The results indicate a significantly strong and significantly positive relationship between CSR and CL. Now you need to mention why it's strong, why it's significant. So you obviously denote correlation coefficient with an R 0.716. The significance value P is less than 0.001, or why it's less than 0.001. So we'll discuss this in a bit as well. Okay, so and you press full stop. This, or rather hence H1 is accepted. Sorry. this is table, let's say this is table 2, correlation analysis. And this is, how do you format this table? Very easy. First, just copy this and put it at the end here. Add a note, because in APA we add a note when we are putting something at the end of the table. Now, this is slightly different from the earlier one. We normally do not report Pearson significance and actually we do report them, but we do not add caption, and we do not report N in correlation analysis. So what we do is we go to layout, we go to draw table, and we complete this cell first. Now this is a separate row, and we delete this row. Now we've got only 2 rows. Now what we do next is, again, select the table, go to layout, draw table, and make it a separate column so you can further delete it. See, this is okay, this is a separate column. Now you select this column. Okay, now this is not a separate column because the other column is getting selected as well. Now this is a separate column. You press, after you've made the selection, you press backspace. Now this is deleted. Now what you do is, obviously, you need to remove this significance as well. So you do is, you remove this significance. Now this is how you report your correlation analysis. This is how you format your correlation analysis. And similarly, you can have multiple variable in a single correlation analysis. I hope this helps. If you've got any questions pertinent to correlation analysis, you can ask those questions and then we'll move forward as well. Any questions, please? Anyone?
I guess no questions.
No questions?
Sir, a female asked about this Anova test and Anova test. So if you can do that later.
Yes, okay.
Because she belongs from pharmacy.
Okay.
And some guys are from CS, I guess.
Okay.
So,
okay. Let's go for Anova test now. Before we go for or we take on Anova test, let's discuss a few things. Now, Anova test is used to identify or measure differences. So what if I've got a data, and let's say I've got a data about, say, satisfaction, maybe loyalty. And I want to know whether the loyalty perception differs between male and female respondents. So in order to do that, I would need to run a test that compares these responses between male and female respondents. Let's say I've got this data and I've got this variable called customer loyalty. Now, my question is, or my research wants to find out, or I want to find out whether or not there are differences in the perception of loyalty between male and female respondents. So let me put my question in. Let's say I've got this question and let's say this is my hypothesis, H2. There is a significant difference in customer loyalty between male and female respondents. Now, this is my hypothesis. What I want to do is I want to assess, I want to evaluate whether there are differences, in customer loyalty between male and female respondents. So how do I do this? Now, in order to do this, you need to run a differential test. You need to compare the means. And how do you compare the means in SPSS? You use independent samples t-test. Now, what's the difference of independent sample t-test with one-way ANOVA? Obviously, we'll be discussing this in a bit once we do the one-way ANOVA. So in order to do this, what you do is you just press independent sample t-test. You go down, and I'm interested in customer loyalty. You put that in test variable because this is the variable that you are testing. And the grouping variable that you are interested in, the variable in which you want to see the differences or assess the differences, is gender. So you add this gender variable over here. Now you see these two question marks. So now you have to define your groups. So in this case, the group 1 is male is 1, the other group is female 2, and then you press continue. So you might have noticed there were only two question marks. So this means that independent sample t-test can only be used when you are looking to assess the differences in two groups. So if you've got more than two groups, you would need another test. And that is what we refer to as one-way Anova, which we'll be discussing in a few minutes. And what you do is you go to options. There's nothing to write in options, that's fine. And you just press OK. Now here are the results. The first is group statistics. Now if you look here at the group statistics, gender 1, male, there are 414 male respondents. The mean is 3.91. The standard deviation is 0.70. The standard error of mean, we are not concerned about this. It's important to note, this is particularly very important, that SPSS will give you hundreds of statistics. But you are not a statistician. The focus of you are using just statistics to help you conclude your study. So you only focus on those statistics that are required by you. Same is the case with any other software. Maybe if you are using AMOS, maybe Smart PLS, maybe M+, maybe Lizrel, it will give you thousands of statistics. So you use only those that can help you conclude your study, finish your study, or report the findings of your study. So, and the female respondents are 360, the mean is 3.80, the standard deviation is 0.69, so all good. Now here, this is independent samples t-test. Now if we look at it, we've got a number of results. So let me copy this for now to our Word document so we can easily discuss it. Layout, let's easily. Got any questions, you can obviously put them in your chat box as well. So I'll look into it and I'll answer them. Okay, let's copy this table that from SPSS here. Okay, now if you look at this table, let's make it concise so that it fits the window so that we can easily discuss it. Okay, now let's go back a little, and we did say that whenever we want to assess a relationship or maybe assess something, we propose hypotheses in our research. In this case, I've proposed this hypothesis that there is a significant difference in customer loyalty between male and female respondents. Now, in order to substantiate this hypothesis, as I mentioned above, I need significance. This will help me identify whether my hypothesis is accepted or my hypothesis is rejected. So in this case, an accepted hypothesis would mean that there are significant differences in customer loyalty between male and female respondents. But if the hypothesis is rejected, this would mean that there are no significant differences in customer loyalty between male and female respondents. And both male and female respondents show a similar pattern in customer loyalty. I hope this is clear up till now. If there is any question, please ask. So I can obviously, if there is no question, I'll just go ahead and move forward. Okay. So now the problem is, if we look at this table, we've got two significance. One is this, and then we've got two other here. So which one do we use to assess whether our hypothesis is accepted or rejected? In this case, both significance two-tailed look the same, but that's not always the case. So how do we know whether to use this value in the first row or whether to use this significance value in the second row in order to accept or reject the hypothesis? Now, in order to do this, we would need this significance value. Now, let me write it, if the Levene's test for equality of variance is greater than 0.05, let me write it, if the significance in Levene's test for equality variance is, then equal variances assumed. Otherwise, equal variances is, or rather not assumed. In this case, this is greater than 0.05. So once this is greater than 0.05, we will use this top row to assess whether our hypothesis is accepted or rejected. But what if this value was less than 0.05? If this value would have been less than 0.05, we would have used this second row. But in this case, we will use the first row. We need to remove this second row. So how do we remove this second row? Simple as we have done before. We'll format this table to make our life easier. So what you do is you go here, you go to the layout, this. Now, so in this case, equal variances assumed. Since we know, so we don't need this either. So let's remove that either, that from the data, out of it to window. Okay, now we know that we need to use this value, and this value is less than 0.05. So this means that our hypothesis is accepted. This means that there are significant differences in customer loyalty between male and female respondents. Clear? Okay, if this is clear, we can move to one-way ANOVA. I hope there is no question, or if there is any question, please do ask. That's the whole point of this session. You have to ask your question. If I do not know the answer, we can obviously, I'll get back to you later with answers in our next workshop. Umar, if we can have a group as well, or actually you have a group, I think. So if they've got any question, and if I do not answer them now, or if I fail to answer them now, obviously we can share my response, or Umar can share that response with you later in that particular group.
Yes.
Okay.
I will share with them.
Umar, can you speak up a bit, please?
Sir, I will share with them.
Okay. So any question for now? Any question, please?
Sir, before going to Anova, sir, can you wait a while, because the specific female has been disconnected and she texted like.
Okay, let's have a 10-minute break. Let's have a 10-minute break because it's been like over 1.5 hours. Let's have a 10-minute break and then we can come back again. Would that be fine?
Okay, sir. Okay,
yep.
Sir.
Okay, let me end the meeting for now and then we can obviously.
Okay, sir.
Okay. I'm just pausing the meeting for now. Okay, so you all can pause the meeting as well.
Okay, sir.
Okay. Okay, we are back. So we were doing independent sample t-test. Now we will move towards doing one-way ANOVA. Now, since previously I gave example about pure management sciences, how maybe say customer loyalty differs between male and female respondents. Now, independent sample t-test can be used to in any number of research studies. For instance, a medical science student may use independent sample t-test to study two groups. So one that is given a particular medicine, while other group might not be given a particular medicine. The control and placebo, as we normally refer to them. So that's how you can use independent sample t-test. For example, in current stages, a particular medicine or a particular COVID-19 vaccine or different COVID-19 vaccine may be tested in different groups, or maybe a COVID-19 tested vaccine tested in two groups to assess how far-reaching its effects are on those two groups, and then the outcomes can be compared. For example, a particular diet plan, how it affects one group and how it affects other group. So this is how you can compare the different groups using independent sample t-tests, provided that you only have two groups. Now moving on, moving ahead, we'll use now, what if let's discuss this example. What if you've got more than two groups? But let's say, what if you want to assess whether or not a particular diet plan, or how a particular diet plan affects three groups, or how a particular medicine affects people in different age groups. For example, maybe blood pressure of people taking a particular medicine, and then their age group is between 20 to 30. The other group may be 30 to 40. The other group may be 40 to 50. So now there are three groups. Now you want to check the blood pressure of people, but these people are from three different groups. So once there are more than two groups, you cannot use independent sample t-test. Now in order to use or in order to compare more than two groups, you would need Anova. Now to do that, you have to go back. In this case, since we've got this data, so what we'll be doing is that let's see if I want to, or I am interested in identifying or assessing or ascertaining whether or not there are differences in loyalty or in loyalty across the three countries that we surveyed. So we surveyed three countries. We collected data from China, Pakistan, and Italy, 1, 2, and 3. And now I am interested in identifying or assessing whether the perception of customer loyalty, or let's say whether the perception of CSR differs between China and Pakistan, or across China, Pakistan, and Italy. So how do you do this? So you click Analyze, you go to Compare Means, and then you click One-Way Anova. I'm interested in identifying or assessing differences in CSR across the three countries. So the factor is country. We'll be discussing post-talk. You go to options, and then you do homogeneity of variance. This is the same as we did equality of variance in independent sample t-test. And then you try descriptives as well. So select these two options, descriptives and homogeneity of variance test. You press continue and you press OK. So you are provided with three tables, 1, 2, and 3. Now again, my hypothesis is, let me put my hypothesis, H3. There is a significant difference in CSR perceptions across China, Pakistan. So this is my hypothesis. Now, in order for me to accept or reject this hypothesis, I have to assess the significance level. Now, where is this significance? If we look at this output and this Anova table, here is this significance, 0.000. This is actually showing us or telling us, yes, there are significant differences in the perception of CSR across these three countries. Like the perception of China is different from the perception of people of Pakistan. And the perception of people of Pakistan might be different from people of Italy. Or the perception of people of Italy might be different than the people of China. So And if you look at this means here, this is actually complementing these significance tests. 4.08, China has got 4.08. The perception rating is 4.08. They are highly approving these. They have got good perception of the CSR initiatives taken in their country. Pakistan 3.65. Italy 3.98. The highest is in China, the second highest in Italy, and then the last is Pakistan. So through naked eye, if we assess the means, there are differences. But if these differences are significant, yes, these differences are significant because the significance value is less than 0.05. So our hypothesis is accepted. There are differences. But now the question arises, whether the difference between China and Pakistan is significant, or whether the difference between China and Italy is significant, or whether the difference between Pakistan and Italy is significant, because there are multiple groups. Overall, there are differences. But are there individual differences existent between China and Pakistan, Pakistan and Italy, and China and Italy? Because these are the only comparisons that you can make since you have got three groups. So how do you do this? I hope I'm clear up till now. If there is any question, please do ask. Any questions? Okay. So what if I want, or what if I ask you, is there significant difference in CSR perception between China and Pakistan? So with this or with these three tables, you cannot be sure. You can only assume that, okay, if there are differences across these three countries, because the significance value is 0.000, less than 0.05, you can say, well, okay, we can assume there is difference between China and Pakistan, but I want you to be sure. I want you to provide me with a significance value. So in order to do this, you will need to first assess whether the equality, you need to assess the equality of variance. In this case, it's 0.125. And when it's greater than 0.05, when the equality of variance test or Levene statistic and the significance in Levene statistic is greater than 0.05, this means equal variance assumed. In this case, the equal variance is assumed. Now, in order to assess whether there are individual differences between these countries, I need to conduct another test. So what do I do now is I go to analyze, I go to compare means, and I go to one-way Anova. And here I've already got CSR, I've already got country. So what I need to do is I need to go to post hoc analysis. And in post hoc analysis, if you see, you've got one group which is labeled as equal variance assumed, the other group which is labeled as equal variance not assumed. So before you click this post hoc analysis, you have to assess this test of homogeneity of variance. And in this case, when we assess the homogeneity of variance, it was greater than 0.05. So since it was greater than 0.05, equal variance was assumed. Now, there are multiple options that you can choose from. Normally, LSD or Bonferroni is used. So in this case, we used LSD. Do not do anything, just press continue and press OK, and you will be presented with another table apart from those tables. And if you look at this table now, it is giving you individual comparisons. Let me copy this in Word so that I'm in a better position to explain. So overall, we knew that there are differences. Now we know that whether China and Pakistan have got any significant difference. Yes, there is a significant difference in the perception of CSR between China and Pakistan. What is there any difference between China and Italy? No, because the value is greater than 0.05. So this is why you need multiple comparisons and post hoc analysis in order to assess the individual differences. Okay, good suggestion. Okay, now homogeneity of variance. Basically, since you are doing study or you are conducting research that has got different groups. In this case, we have three groups. One is China, that people belong to China, respondents belonging to China. This is one group. Then there is Pakistan, and then there is Italy. So these are three groups. So what do you mean by equality of variance? Equality of variance here means whether the data distribution in these three groups is the same or not. So if the data distribution is the same, in case of independent sample t-test, or in case of multiple comparisons or one-way ANOVA, we use different tests. In this case, since the equality of variance, the distribution of data in these three groups was almost similar, since it was greater than 0.05. So we used, in the post hoc comparison, we used LSD. Now, since we were interested, now, before running this multiple comparison, this ANOVA table provided us with a significance value. Now, this significance value helped us highlight overall whether our hypothesis is accepted or rejected. Overall, our hypothesis was there are significant differences in CSR perceptions across Pakistan, China, and Italy. Now, whether this hypothesis is accepted or rejected, you go and look at your ANOVA table. Yes, this hypothesis is accepted. Yes, there are differences in CSR perception across Pakistan, China, and Italy. But this is significance, whether or not your hypothesis is accepted or rejected. But if I ask you this question, whether there are differences in China and Pakistan, or China and Italy, or Pakistan and Italy, you need another test. And this is called post hoc test. To run the post hoc test, you need to first assess the homogeneity of variance. In this case, the homogeneity of variance was insignificant. This would mean equal variance assumed. And you select a particular test from equal variance assumed group from the post hoc that we did. I'll do it again. Analyze, compare means, one-way ANOVA, post hoc, and we selected LSD. You just press continue and OK, and you are displayed with this table. Now look at this table. It is giving us individual differences between countries. The perception of CSR between China and Pakistan is significantly different. But the perception of CSR between China and Italy is not significantly different, because the value is greater than 0.05. Now this is how you assess, this is how you know whether or not there are differences between the variables, the groups. Similarly, you can assess, it's the same Pakistan and China, it's repetition. So you need to, when you are formatting your tables, you need to remove the repetitions. But there is something new here, Pakistan and Italy. So is there a significant difference in the perception of CSR between Pakistan and Italy? So let's say Pakistan and Italy. Yes, there is significant difference. Now the last row is obviously a repetition of what we have already got, so you can obviously easily remove it. So this is how you can use ANOVA to assess or evaluate differences in multiple groups, obviously greater than 2. Okay, any questions regarding ANOVA? Okay, if there are no questions, we'll go to our final test, chi-square analysis. And obviously, okay, now let's say, let me create a new data set for chi-square. Okay, there is a very big misconception regarding the use of chi-square. People tend to use it for anything, any sort of relationship. This is utterly wrong. Chi-square is only used when you've got your data in nominal scale, or nominal and ordinal scale. So you cannot use chi-square analysis for any kind of analysis. If your data is in interval or ratio scale, you cannot use chi-square analysis, because the results will be wrong. Obviously, SPSS will give you results, but those results will be wrong. Let's say I've got a data, gender, and I've got a data about preferred color. So let's say we've got different colors. One is blue, two is green, three is pink, and four is, and then we've got one male, two female. Let's say we've got, let me enter some dummy data here. We've got 23 male and we've got some, and let's say the preferred color for male is one. Now we've got data from 37 respondents, and each respondent identified their preferred color. Now both these variables are in nominal scale, so there is no order in the color. It could have been, I wrote blue first, I could have written black first. This wouldn't have made any difference at all. So now I need to know whether there is an association between gender and color. So what I do is I go to analyze, and then I go to descriptives, and then I go to cross tabs. In row, I can add gender, whatever is visible to you, whatever is readable to you, you can obviously switch. You can add gender to columns or rows to column, color to columns, that doesn't matter. And then you go to statistics, and then you click chi-square. You press continue, and you press OK. And here are your results. Now, in male, the preference is 11 have preference for blue, 11 have preference for black, 1 has preference for green. In female, 9 have preference for green and 5 has preference for pink, and there are total 14 female respondents, 23 male respondents, a total of 37 respondents. Now if we look at this table, there are multiple statistics, but what we are interested in is the top row. 33.174 is the chi-square statistic. But what we are interested in is whether there is a significant association of gender and color. Yes, there is a significant association of gender and color, because the p-value, the significance value, which if less than 0.05 shows significant relationship. In this case, the value is less than 0.05. So your hypothesis is accepted. This shows, yes, there is a significant association between gender, or there is a significant association of gender with a particular color, or you can associate color with a particular gender. So this is how you can use chi-square statistics. Thank you so very much. Now I leave the floor open to any questions, any suggestions, because your suggestions are more than welcome to further improve this process, because obviously we'll be in touch. This was just a basic orientation to SPSS. In future, we obviously plan on delivering lectures on how to write in a particular paper. What makes your paper worthy of publishing? So we'll be discussing all those things. We'll be discussing advanced softwares like Smart PLS, maybe Amos, Atlas.ti, and Mendeley. How to use Mendeley not just for referencing, but to write your literature. So we've got a number of concepts in mind, ideas in mind, and we will strongly recommend if you can obviously provide your input. If you don't want to talk, obviously you can put your input in chat box, and we'll definitely consider those things, and we'll obviously try to make sure to further improve this initiative and make it as fruitful as possible for you all. So the floor is open for questions. You can ask any question. Yes, please provide your any comments, any suggestions, any input you want, any questions if you have.
Thank you, sir, for giving us your precious time. I guess if someone asks a question, so it will be more than welcome. no questions, I guess.
Okay, if there are no questions, this means you did not understand anything or you understand everything. So anyways, yes, Fawad, more or less, if you've got any question, you can ask. And obviously we can, since we all are at home, so we can obviously take this further. If you've got any request that you want a particular thing or you want to learn a particular thing, obviously we can take that into consideration as well. And then obviously we can come back maybe sometime this week, maybe next week. You can practice on it. You can obviously put your questions. Okay, factor analysis. Okay, let's do a bit about factor analysis since we are online and since you are interested in factor analysis. Umar, would that be fine? Can I go for factor analysis a bit?
Yes, sir. Sure.
Okay, Fawad, since you've asked for factor analysis, now there are two forms of factor analysis. One is exploratory factor analysis and one is confirmatory factor analysis. SPSS is equipped to conduct exploratory factor analysis, not confirmatory factor analysis. Now, if you want to do confirmatory factor analysis, you have to go to Lizral, you have to go to AMOS, you have to go to M+, not even Smart PLS. Smart PLS is for structural equation modeling. It's not for confirmatory factor analysis. SPSS is only for exploratory factor analysis. Now, what's the difference? Rather than going into the difference, let me talk about exploratory factor analysis. Now, if you've got a few factors, a few, maybe say a few things related to a particular concepts, and there are maybe say these 20, 30, 40, 50 factors that are related to a particular concept, and you want to group those factors into underlying constructs or underlying, you want to identify whether there is an underlying grouping in there. So what you do is you go for exploratory factor analysis. Normally, exploratory factor analysis is used for scale development. I hope you can see the screen. Everyone, Umar, screen visible? Sorry, screen
Yes,
is
sir.
visible, right? Okay. Now,
Yes, sir.
let's say we've got this paper. This is one of our paper. Let me put the paper. Okay, this is one paper. This was written by Umar and me. So what we did was we developed a scale, a multi-dimensional scale for measuring internal marketing in Chinese higher education. And what we did was we did a few interviews. And then based on those interviews, we identify the key items that can make up the internal marketing scale. After that, we had 36, 37 or whatever the number of questions we had. Umar will share this paper with you as well. So now we had these questions after, initially we had this is the number of questions we had. So now we wanted to identify whether these items, these questions can be grouped together or not. Now, we did our own grouping as well, but obviously when you are doing statistical analysis, you want to support your findings through statistics. So in order to do this, the option is you have to conduct exploratory factor analysis, and you have to identify whether the categorization that you have done actually is true or not, whether your item fall in place as you expected or not. So you've got 10 questions and you say, okay, these questions should fall into 3 factors, with first 3 questions in factor 1, second 3 questions in factor 2, and the last 4 questions in factor 3. So in this case, we did EFA as well. And once we did EFA, a number of items were removed. These were the removed items because they did not fall into their particular factor or their loadings was low. And this was our EFA results. So only 3 items went into the factor 1, which was IC. And similarly, other items into their respective factors. So you remove items, you remove factors that are actually, or that do not fall into place that you expected. So how do you run factor analysis? I hope I'm clear up till now, and then is everything clear? So since Fawad specifically asked for it, so I'm going to ask Fawad. Okay, good. Okay, Fawad, let's say we've got this data. Okay, Fawad, this is our data. Now, this is actually a paper on scale development in servant leadership. So I've got these questions. I actually, the scale development is a whole process. I'm not going to get into detail of how it works. We can have a separate session on that as well, if required. So now what I did was I drafted a few questions. There were 37, 38 questions. Now, those 37, 38, 39 questions, we asked those 37, 38, 39 questions from public sector employees. Now, they provided their response, and now I want to check whether the factor structure that I assumed would be there is actually there or not. So I did categorize my factors, my items, my questions into different categories. For example, authenticity had 5 questions, behaving ethically had 6, development had 5, emotional healing had 5, humility had 5, wisdom had 7 questions. Now, this is what I expected. Okay, these questions actually belong to these categories, but now I have to check whether I was right or wrong. Now, in order to do this, I have to go for exploratory factor analysis. Now, to do this, you go to analyze, dimension reduction, and then factor. Now, shall I check them separately or all together? That's the question. You should check them all together. Reason being, these are the factors that relate to a particular construct. And in this case, the construct is servant leadership. I had around 37, 38 questions, which I categorized into 1, 2, 3, 4, 5, 6 categories. Now I want to be sure whether the categorization or putting these items into these categories was right or wrong. So I select all these items, drag them or put them into variable list. I go to descriptives and I select KMO and Bartlett tests. I press continue. I go to extraction. It should be principal components. Then I press continue. Then I select rotation, select Varimax. And then maximum iteration, leave it default. Go to options and suppress small coefficient. This should be 0.50. What does this mean? This means that you only have values in a particular construct or in a particular, the loading would show only in a construct where it loads over 0.50, where it shows substantial loading. It would not show everywhere. Let's keep it 0.10. And if you leave it like this, and if you press OK, look at the results here. You can look at the results and you'll see, okay, rotated component matrix. Now, this does not make sense. You do not know whether the items, this 81, 82, 83, and these are the items, BE1, so on and so forth, they are on which factors they are loading primarily. You have to look into detail. Okay, I do not know where it's loading. Oh, sorry. Okay, let me share. Okay, now once you press OK, you are shown results and you have to go to rotated component matrix. Now, if you go to rotated component matrix, you see this table, with all these statistics, with all these numbers. And this does not make anything clear. If I ask you this question, this is 81, 82, BE1, BE2, so on and so forth. Now, if I ask this question, 81, where is this particular item loading well? Is it loading onto factor 1? These are 6 factors. So these 30 items or so are loading onto 6 factors. So whether 81 is loading onto its respective factor or not. So this doesn't make it clear. So in order to make it clear, what I do is, in order to make it readable, you go to this option and you select 0.50. And once you select the minimum loading value, you press continue, you press OK, and you go to rotated component matrix and see, this is much clearer than the previous table. Now you know that, okay, 81 is empty. Now, once this is empty, this means that 81 failed to load onto its respective factor. It did not show enough loading. It's just like 81 is not representing its factor well. So you cannot use 81 in your study. If you see 85 is loading not, now 82, 83, 80, 84, they are loading together. So this shows that 82, 83, 84 are a particular construct or a particular factor because they are loading well. But 85 is not loading together with 82, 83, and 84. This means that 85 is failing to represent 80. So you have to remove 80 from your study, 85, sorry. BE1, BE2, BE3, BE4, BE5. 5 items are loading well together, but BE6 is not loading anywhere. This means that BE6 fails to represent its underlying construct. All other, similarly, you see all other factors are grouped together, loading together. This means they are representing their underlying construct well. So let's remove 81 first. Do not remove all of them together, because sometimes just removing one item can obviously put all things in place. So I just remove 81 and let's see how it works now. See, 85 is still problematic because it's not loading onto its respective factor where all other items are loading. So I remove 85 as well. So go to analyze, time reduction, 85. And then you press OK and rotated component matrix and see, I think it's very well in place now. Everything falls in place. Everything is doing really good now. 81, all items together, BE, all items together, DP, all items together, EH, all items together, HM, all items together, W, all items together. Now, how do you report it? How do you interpret it? I request Umar to share the papers with you on the group, so you know how to report it, how to group it. I'll share the papers with Umar and Umar can share it with you. Now, see, how many factors did you expect before conducting your exploratory factor analysis? You were expecting 1, 2, 3, 4, 5, 6 factors, and what you got was 6 factor. So very good. So each factor. So how many factors to extract? You only extract factors that have got eigenvalue greater than 1. So you put that in options as well. There is an option. So if you go to extraction, see, based on eigenvalue 1, this is a criteria. How many factors can you have? You can have as many factors as the number of items in your study. In this case, you had 31 items, so you could have 31 factors. But we do not want 31 factors. We want those factors to be grouped together. So in this case, we keep it 1, that's the default value. Is the data suitable for factor loading? Well, yes, because the KMO, Kaiser-Meyer-Olkin measure of sampling adequacy is greater than 0.60. It's 0.297. So this is how you run exploratory factor analysis. In order to report it, Umar will obviously share the paper in the group. If you've got any other question, obviously I'm here to answer.
I guess no questions, sir.
Okay. Thank you, everyone. Umar, if you want to add anything, if you want to say anything about our future prospects, kindly explain which option to be taken for rotation. Okay, Verimax. You can take Verimax option. That's normally used. It's good to have. It's good to take Verimax rotation, but you can plug and play with it. It's exploratory factor analysis is more or less trial and error. You move items, you add items, unless or until you get your desired solution or factor structure. Yes, we will focus on M plus multi-level modeling, but first let's get the basics out of the way. We will focus on M plus, the mediation and moderation using M plus, but that will come obviously at a later stage. Umar, if you can conclude, please. Thank
you, sir. Actually, we'll discuss some more softwares in the future. So I will share it with you, and we can plan it with the students as well.